Hello everyone, I'm Abhishek from minervaa and today our discussion topic is work. So basically what I mean by work, actually the work done in physics is defined by that suppose there is an object, right, which having a mass of m, and if you apply some force on that object, then obviously the object will move if the applied force is an unbalanced force, right? The applied force should be an unbalanced force so that the object can move, right? If we apply a balanced force, then what will happen? The object will not able to change its state, because in Newton's first law you will going to know that when you will apply some unbalanced force, then only the object can change its state. Now in this case you have applied some unbalanced force, so that's why the object is getting displaced that amount of distance, right? So what is the displacement here? Now the displacement that is equals to s, right? So in physics the definition of work done that is equals to if you are applying some unbalanced force to an object, and that's why the object covers some distance, right? That means suppose there is a car, you have applied some force and the car moves some distance, right? If suppose there is a box, you have applied some force and it moves some distance, so you have just done some work. So what is the work done in this case? The definition of work done involves two quantities in this case. So what is the work done by this body? The work done by this body, that is the force that is applied on it, and for which what is the value of displacement, right? If they both should be multiplied, then you will get the value of work done, which is represented by W, right? So work done basically that is of F multiplied by S, and what's the unit of it? If I talk about the unit of work done, then it will have two units. One is units of work done. Units of work done, if we just describe, then we will have two units. One is the SI unit, another is the CGS unit, right? So what is the SI unit of work done? As you can see, this is the mathematical expression of work done. According to this, the formula that is to calculate the unit of it, that is Newton meter, right? So SI unit of work done, that should be Newton meter. Newton meter can also be expressed as Joule. According to the name of a scientist, it is named as Joule. In CGS, it is about dyne centimeter, right? As the CGS unit of force, that is of dyne, and CGS unit of displacement is centimeter. So dyne centimeter is known as arc, right? So lots of complex things we have described here, right? There is an object, we have applied some force and that displaced, right? So in basically what happens in our daily life, we have seen lots of practical examples of this work done, where in lots of cases, even I can give you a practical example also. Suppose there is a marker, okay, and I have applied some force and it is displaced. That means the marker has done some work, right? This is a small practical experience. Now in this case, the SI unit and the CGS unit, both we know. So what is the basic relation between the Joule and arc? Let's see. The relation between 1 Joule and 1 arc. Now what do you know? That 1 Joule, that is equals to 1 Newton multiplied by 1 meter. Right? We know that 1 Joule, that is of 1 Newton multiplied by 1 meter. So 1 Newton equals to how much dyne? That's a basic concept. 1 Newton, that is equals to 10 to the power 5 dyne. Remember this concept. This is a very important concept that will help you in a lot of cases. So I can write it down that it is of 10 to the power 5 multiplied by 10 to the power 5 dyne, obviously. And 1 meter equals to 100 centimeter. That means it should be 10 to the power 2 centimeter. So I can write it down that 1 Joule, that is equals to 10 to the power 7 dyne centimeter. And it is equals to 10 to the power 7 arc. So the final expression that I have got, that 1 Joule equals to 10 to the power 7 arc. right? This is the important relationship between the CGS and SI unit of work done, right? So what's the basic questions that come from the small concept? Let's see the applications. So the first application I'm just going to write down here. So if we have an example like that a body of 20 kg, it's a heavy weight, right? A body of 20 kg is displaced by 20 centimeter after applying a force of suppose 50 Newton, right? So a body of 20 kg is displaced by 20 centimeter after applying a force of 50 Newton, right? So what do you have to find out? You have to find the work done, that is W. So let's suppose this is the body which having a weight of 20 kg, right? You have applied a force of 50 Newton and that's why the body is displaced, right? How much it is displaced? It is displaced by 20 centimeter, right? Am I correct? So it is displaced by 20 centimeter. So in this case, how to find out the value of work done? What do we know? Work done means work done by that body, that is equals to the force applied on it and how much the displacement occurs. In this case, the work done by the body, that is equals to the force that is applied multiplied by the displacement. So in this case, the force you have applied, that is of 50 Newton, but here the displacement it has done, that is of 20 centimeter. So be careful about that. In some questions, these are some kind of very short tricky questions where the units are interchanged. One of them will be in SI, another of them will be in CGS, right? So you have to just convert it. That is 20 centimeter means 20 by 100 meter, right? So that is of 5 and it is of 10. So the work done, that is of 10 joule. As simple as it is. But if you have done any mistake by placing only 20 over here, you will get 0. So be careful about that. Check all of the units as first. Actually, the steps that we follow, that when we have a question, we should collect all of the information given in that question, right? One thing you will notice that in this case, the mass of the object which was given 20 kg, it is not needed here because the value of work done is depend only on two things: the force you have applied and the displacement it has done, right? So now let's move to the next concept, right? Now, how many types of force you can apply? Only we have applied in this case a linear force. Now, if that force should be angular, let's suppose we are angular pull or an angular push. So in that case, how to analyze that one? Let's see. Now, I hope your trigonometric concepts are very good because in this case, the concepts will be used here. Now, suppose we are giving an example. What's that example? Let's see. There is an object. Okay. There is an object which is having a mass of m. Initially it is given. And you have applied a force like that. There is a force that is of capital F. And it is applied at an angle of theta. Right? After hearing that word theta, you think that how much complex it's going to be. But it is as simple as possible. So, there will get two components of that applied force because we are applying that force with an angle with respect to the horizontal, right? So in this case, what are the two components? One component along the horizontal, another component that will work along the vertical line. So how to derive that components? We don't know that one. Now we have already told you that the trigonometric concepts will be used here. How? Let's see. In trigonometry, actually what happens, suppose this is your right angle triangle, right, where angle B that is equals to 90 degree. We should learn some mathematics also here. So in this case, if that angle that is equals to theta, I'm talking about that theta. So in that case, if I just find out the trigonometric ratios, because I need just two trigonometric ratios, one is sine, another is cosine, right, that is named as cos also. So what is the value of sine of theta of that angle? Sine theta, that is equals to perpendicular divided by hypotenuse. So in this case, the side opposite to that of angle, that should be the perpendicular divided by the hypotenuse, that is obviously AC, right? So in this case, what will be the value of AB? That is, I'm just finding out the length of the perpendicular. So in this case, even it is not actually the length also, in that direction, that means in the perpendicular direction also, if you want to represent something, that can be find out by the value of AB also. So the value of AB, that is of AC sine theta, right? This is your suppose equation number 1. With that equations, we are not going to do anything, just stay calm and see that what is happening here. At first we have found the value of the perpendicular component, that is equals to the value of hypotenuse multiplied by the sine theta. Now what we will find out? We will find out the cos component, right? That is named as cosine as well. So cos of theta, that is equals to base by hypotenuse. So what is base here? That is of BC. And what is the hypotenuse? That is of AC, right? Now if I just cross multiply, then what will happen? That is of BC equals to AC cos theta, right? That should be your equation number 2, right? In this case. So this is your equation number 1 and that's your equation number 2. Why I have found that one? Why I have told you that trigonometrical concepts will be used here. That's why we have find out the perpendicular and the base. Here AB is the perpendicular, we have the value of AC sine theta, and here the value of BC we have as AC cos theta. Now along AC, that means if we just think about that this is our right angle triangle, if we think that this is our right angle triangle, so in that case, as you can see that the hypotenuse is represented by force F. So in this case, what will be the value of the horizontal component? That should be the hypotenuse multiplied by the cos theta. In this case, as you can find out that this is a one type of right angle triangle, right? So along the base, there should be a component of that force. Here, the hypotenuse is represented by the force F. So what should be the value of that horizontal component? The horizontal component BC, that is equals to AC cos theta. AC is the hypotenuse. So obviously it should be F cos theta, right? And what should be the value of its perpendicular component here? The perpendicular component can be represented by that. So the value of perpendicular component, that is of here, that is like hypotenuse multiplied by the sine theta. So in this case, the hypotenuse, that is of the value of F, so it should be F sine theta, right? Along this. That one you don't need because they both are same. Along this line or along this line, you can represent F sine theta. But we are not dealing with only trigonometry. Here we are applying the concept of trigonometry in physics. So that's why along this line the force cannot work. The force should be work along this line because you are applying that force, so it should have some horizontal component, it should have some vertical component, right? Now, after applying that amount of force, if the body is displaced by that distance, now the object is at point, right? The object is now at this point. Let's suppose this is your point, this is your point A and this is your point B. So after applying the force, now here the force that is of F cos theta only be considered, because after applying that amount of force the body is displaced, right? Now here if the displacement that is equals to S, that you always consider. If the displacement that is equals to S, now what should be the value of work done here? The value of work done, that is equals to the component of force which is responsible for its displacement, that is of F cos theta multiplied by the displacement. What is the displacement here? That is S. So we should multiply them, and the final formulative representation of work done, that will be Fs cos theta. So work done, that should be equals to Fs cos theta when the force should be applied at some angle. Now in this case, we'll see the application of that concept in the next question. Now if we have a question like that there was an object, right, which having a mass of 5 kg. It is given in that question just to make you guys confused. Now you are applying a force of 20 Newton with an angle of 60 degree, right? After applying that amount of force, if the object is displaced by that distance, now the mass of that object will remain as it is. Now in this case, the displacement is given. The displacement is 40 centimeter, right? So you have to find out the value of work done. Now just see the question. What is given here? The value of applied force, which is given as 20 Newton. The angle at which it is acting, that is of 60 degree. The mass of the object which is given here, that is of 5 kg, but it is of no use. You guys know that. And the displacement, that is of 40 centimeter, right? So at first check all of the units that is given here. Whether all of the units are in series or are in SI. So in that case, all of the units are not in series or not in particularly SI. The force you have, that is in SI, but the displacement, that is in series. So you have to just convert it. It should be 40 by 100 meter, that is of 0.4 meter, right? So what will be the value of work done? The formula we know to calculate the work done, that is of force multiplied by displacement and the cos of theta, right? So for that case, the force here in this case, that is of 20 Newton multiplied by, what is the displacement in this case, that is of 0.4 multiplied by the cos of that angle, that is 60 degree, right? So in this case it should be 8 multiplied by cos 60. What the value of cos 60? That I know that the value of cos 60 in this case, that is of half, right? Now I will give you a trick, thus that you can remember all of the values of the trigonometric functions. Don't worry for that. Let's calculate that at first. Now it should be of 4 joule. Now the answer of this question, that should be of 4 joule. That means if you apply a force of 20 Newton at an angle of 60 degree and the body is displaced by 0.4 meter, then the work done by that object, that is of 4 joule, right? So let's see another concept. Now in this case you have applied a pull, right? Now if you have applied a push on that object, then what will happen? Let's see. Now let's see another concept. When there is an object and you are applying some push on it. Now in this case, the force you have applied, that is same, that is F here, and in this case the angle at which the force is applying, that is of theta. Now in that case, how to determine the work done? Now as we know that the horizontal component that is working here, that is obviously of F cos theta, and the vertical component, in which direction the vertical component will work. Now when you will apply some push force, that means the vertical component should be in the downward direction in this case, because after applying the push force, the horizontal component will be as it is, but the vertical component will be changed. You are not pulling anything, you are just pushing anything, right, in the downward direction. So obviously the vertical component of the force will obviously work in the downward direction. Now the object is having a mass of m. Now the mass of that object and the weight of the object will not be considered in the calculation of this work done. Now in this case, if you have applied a push force over here, the horizontal component and the vertical component we have derived. Now after that, if it is displaced by a distance of s over here, so what will be the value of the work done? As here you can see the vertical component has been changed, so whether this will affect the formulative representation of work done, Obviously not, because in this case the work done that happens here because of that f cos theta only. Because of that f sin theta, it will not be affected. So what will be the formulative representation of work done? That will be same, because that is equals to fs cos theta. So this is the case of push force, right? Now in the previous one that should be a pull, right? It's one, that one it was a pull force, right? You have applied on that object. So where the application of push force we see in our daily life? Suppose there is an object and you are just applying some push force and it is displaced by some distance. So in that case you can get the value of work done. But remember one thing, in the case of push or in the case of pull, the component of the force that is responsible, that is obviously the horizontal component. And the expression that will remain unchanged, even the units as well, right? So let's see that what are the different types of work done, right? And when the value of the work done can be minimum, maximum or zero. Let's see that. So when the work done will be maximum, minimum and zero. So in this case the value of work done that we know, that is of fs cos theta, right? So when the theta is having a value of 0, when the theta is having a value of 0, that means how it is look like? That means there is an object, that was the applied force and that was an angle of theta. Now if that theta becomes 0, then what will happen? That component will become like that. It will be like a linear force. So in that case the diagram will be modified. It should be like that. It will become a linear force, and on that case the value of work done, that will be maximum. So work done maximum, that is equals to force multiplied by the displacement and cos of 0. So in this case the maximum work done, that is of the force multiplied by its displacement. Now let's see that when theta will be equals to 90 degree. When theta will be equals to 90 degree, now at that case what will be the value of the work done? And where we see the application of that? At first what we will calculate? Let's calculate the formula, that what will come. That is of the work done, that is equals to force multiplied by displacement and cos of 90. What is the value of cos of 90? That is obviously 0, right? So the work done in this case, that is 0. So obviously it is the minimum work done, right? So where you see the application of this minimum work done? Suppose in a railway platform you just seen, right, there are a lot of coolies, right, taking a lot of loads on their head. That means in that case what happened if we just made that one? Suppose this is the coolie that I am talking about and there is the load on his head, right? That means in this case if he is traveling in this way, that means that displacement is going on in this way and the weight of the object is working in this direction as mg. That means the weight of that object that is kept on his head is working in the downward direction, but the displacement is in this way. So the angle between them, that is obviously 90 degree. So in that case the work done, that should be equals to 0. Not in that case, in latter case also we'll see the application where in the case of circular motion. I hope you guys remember that one. Suppose the boring example I'm just going to take here. That is, there is my hand, right? There is an object who is rotating in a circular motion. Now at the time of it is rotating in a circular motion, what happens? Suppose what is the direction of its circular motion? That is obviously given by the tangent. So what is the angle by the line that is joining the object and the tangent here? If you can see that the angle, that is obviously equals to 90 degree. So that means in circular motion the object who is rotating in a circular path, it is obviously having an angle of 90 degree with respect to the line joining to the center. So in that case also we'll see the application where the work done is minimum. Even in the planetary motion, even when the electrons are rotating about the with respect to the nucleus also, in that case the work done, that is minimum as 0. So in this case what happened, that if we take an example of a nucleus, Suppose there is a nucleus, right, and around it there are the orbits along which the electrons are rotating with respect to that, right? So in that case, if we take that example of the motion of an electron, that means it is very much clear that they are also having the angle of 90 degree at the time of rotating in that orbit. Right? If we talk about this electron, it is rotating about this orbit. Now, if you can see that the line joining the nucleus and the electron and the direction at which it is moving, that the angle that is equals to 90 degree. So in the case of circular motion also, when the object is rotating in a circular path, so they are having the angle of 90 degree with respect to its direction, right? So I hope it is clear. Now we'll see that what are the different kind of work done. That is, we have positive work done as well as negative work done. Now in this case, we are just going to learn that what are the types of work done, right? What are the types of work done? One is positive work done. Positive work done. Another is obviously negative work done. So what I mean by that, positive work, negative work. Positive work done, that means in this case, if we just draw a figure, so in this case we are applying a force in that direction, and that's why the object is displaced by some distance of s, right? So in this case you are applying that force, it is a linear force. That means in this case the applied force is having an angle of 0. Right? So what will be the value of work done? That is of Fs cos of 0. So I will get that is of Fs. We have just calculated that amount of work done because this is the expression for maximum work done, right? This is the positive work done. Because in this case, at which direction you are applying the force, the direction is also, because in this case, in which direction you are applying that force, the displacement has occurred in the same direction. That's why the work done in this case, it is positive. So when the work done should be negative, when theta will be equals to 180 degree, at that time what will be the value of the work done? That should be Fs cos of 180 degree. What is the value of cos of 180? That is of -1. So in this case, the value of work done, that is of minus of Fs. So in this case, what are the examples by which we can explain this negative work done? Suppose we are just taking an example of a potter, right? That means he is having something load on his head and he is just coming down. That means in that downstairs he is just coming down. This is the potter and he is having that amount of load and he is just coming down. So in this case, the displacement is in the downward direction, but he have to apply some force in the upward direction. So what is the angle between the force and the displacement in this case? As you can see that the angle in this case, that is of 180 degree because they are directly opposite to each other. So this is the example where we can find out the negative work done, right? Even there is another example also. If you are throwing an object, there is a marker and I'm just throwing it. That means I have to apply the force in this direction. That means the object is moving in that direction, right? So this is the direction for the displacement. But the weight of the object, that means every object is attracted by the earth, right? So it is having a mass of m, so obviously the weight should be in the downward direction. That is a mass into gravitational acceleration. So this is a one type of force that is working in the downward direction and the displacement is in the upward direction. So in this case also, this is an example of negative work done because this is the work done against the gravity, right? So the next topic is that one. What is the expression for work done against the gravity? So up to that we have just covered what is positive work done. That means you are applying that force and in the same direction the displacement happens. That means the expression for positive work done is Fs. And in the case of negative work done, we have taken an example of potter, right? He is having some load and he is just coming to downstairs. So at that time, the displacement is occurring in the downward direction, but the force he is applying on his load in the upward direction. So there is an angle between them that is of 180 degree. So obviously this is a negative work done, right? Even the negative work done expression we have just got as minus of Fs, because the value of theta that is of 180 degree, right? So we'll get a new expression about the work done against the gravity. What I mean by that, suppose if we have a pen and I am just applying some force to pull it at a particular height. So what the work done I have to do to make it move from a point which is on the ground and at a point which is at a particular height h. Let's see it. So we are discussing about work done against gravity. Now the marker pen is at this point, right? So this is at this point and I am applying some force to it to move it at this height, right? So the height it has reached, that is of h. Now at this point the marker pen is like that. So I have done some work to make it reach at this particular height, because in this case I am just applying some force to make it pull at this particular height. So this is the work done against the gravity, because due to gravity the object is attracted towards the earth in the downward direction, right? The object, suppose if this is the object, it is attracted in the downward direction due to the gravity, but I am applying some force to make it move in the upward direction. That means I am doing the work against the gravity. So what will be the expression for that? Work done against the gravity, work done against gravity, that is of what the force you are applying. You are applying the force equivalence to its weight, right? In this case, the marker was like that and I'm just applying the force equivalent to its weight and it's reached at this point. So what the weight of this, if this is having a mass of m, so the weight of it, that should be mass into gravitational acceleration. So in this case, the weight that is of m into g and the height at which it is placed, that is of h. So the work done against gravity, that is of mgh. This is the expression. Now, what is the next topic that we are going to cover? That is power. Power means I am having lot of power, I can break that pen. Is that something we are discussing about it? No, it is not like that. In physics, power is a measure that how much work you can do in a particular amount of time, right? That means the rate of doing a work. So how can we express that? What is the mathematical expression and what is the definition? How can we define that power? I'm having more power. That's muscle power, right? But in this case, the power is different. Let's see. So what is power? Power is the work done. Power is defined by a work done at a particular time. That means I can define power as work done by time, right? Power equals to work done by time. So what should be its units? Let's discuss about that. So units of power. So obviously it should have two units. One is the SI unit, another is the CGS unit. What should be the SI unit? The SI unit should be joule per second. What should be the CGS unit? That should be arc per second, right? In this way I have to define. But you people will say, sir, we have seen that in the case of electrical power, in the chapter of electricity also, if you have that chapter. Now in the case of electrical power, what happens? We express the electrical power as watt, kilowatt, right? So what do you mean by that? What I mean by watt or kilowatt? Actually this joule per second is actually known as watt. That means I can say that 1 watt equals to 1 joule by 1 second. That means that amount of work is done in that amount of time. 1 joule of work is done in 1 second. That means the power of that object, that is of 1 watt. So what I mean by 40 watt? So in this case, 40 joule of work is done in 1 second. So that's why it is expressed as 40 watt. So what I mean by kilowatt, if I write it down, that means there must be a relation between this watt and joule. What's that relation? Let's see. Now the next thing, that is, what is the relation between this kilowatt and joule actually? So in that case, 1 kilowatt, if I write down 1 kilowatt, that is obviously equals to 10 to the power 3 joule per second. That means that amount of work is done in 1 second, right? It is actually 10 to the power 3 watt, right? 1 kilowatt equals to 10 to the power 3 watt. So what I mean by 1 megawatt, that is obviously equals to 10 to the power 6 watts, or you can express it as 10 to the power 3 kilowatts, right? So in the previous times, actually in the olden times, what happens, there was a steam engine. So to express the power of a steam engine, what was done? There was a new unit what was derived at that time. The unit was horsepower, HP. What I mean by HP, it's not actually Hewlett Packard. There is a laptop company, right? So it is actually horsepower. So how it is measured? That means a horse can do some work. So the work done by a healthy horse in a particular time, so this is measured by 1 horsepower. 1 horsepower, that is of 746 watt. That amount of power. That means the work done by a steam engine is expressed with respect to this horsepower. Thus it can be measured with respect to watt. Now we'll see the application. Now we'll see the difference between the work and power. What is the difference between them? Let's plot it. So what is the difference between the work done and power? That means actually work and power, you can say also. So work done, that is equals to the force you are applying. For applying a particular force, what the displacement that happens, that is equals to the work done, right? So the first point, that should be work done is basically the force applied and for which the displacement done by the object, right? This is actually the work done. What the force you have applied and for which the displacement, this is actually the product of force and displacement, right? So you can express it that work done is defined by the force applied on that object for which the displacement is made by it. That is, it is the product of force and displacement, right? It is the product of force and displacement. What should be the point for power? It is the work done in a particular amount of time. That is the work done in a particular time, right? That in that way it should be defined, right? What is the mathematical expression for work done? The mathematical expression for work done, that is equals to the force multiplied by displacement. What is the mathematical expression for power? That is equals to work done by time, right? It cannot be a differentiation, but you can include that one in the last. So what should be the third point? That is, in this case, what is the SI unit of work done? That is equals to joule. And what is the SI unit of power? That is equals to joule per second, right? I'm not writing more. I'm just telling you the points, right? In this case, the work done can be 0, right? Now, in this case, if the work done can be 0, that means the power can be 0 or not? If the work done can be 0, then the power can also be 0. But in this case, the main difference between them, that is, the work done by a body does not depend on time, but the power obviously depends on time, because it measures that how much work is done in a particular amount of time, right? So in this way you can plot the differences between the work done and the power, right? So let's solve lots of numerical problems that we can understand that what are the different type of questions that may ask. in exams. Now, as you can see in this figure, it's a different kind of problem, right? Here, 200 Newton is actually the weight of the body. It is not actually expressed by W, because with the help of W, the work done can also be expressed. So 200 Newton is actually the weight of the body. Now, after applying a force of 150 Newton, it is displaced by 5 meter. So here the applied force, that is equals to 150 Newton, and the displacement, that is equals to 5 meter. Now what is the function of this 4 meter, 3 meter? They should not be used in this case, because you have to find out the value of work done. This is the case of an inclined plane. Now what the force you have applied, that is of 150 Newton, and for this what the displacement, that is of 5 meter. So in this case, the value of work done, that is of the force multiplied by the displacement, so that should be 150 multiplied by 5, that is of 750 joule. So in this way, that complex problem can be so easy, right? So let's take another example and understand what are the different types of problem can be asked. So let's see the example. In this case, a boy weighing 350 Newton runs up a flight of 30 steps each of 20 centimeter high. You have to calculate the power developed here. Now how to calculate the power developed? In this case you have to find out the work done at first, then it will be better to find out the power. So what is the value of the work done? So to calculate the work done, you need two things. One is the force that is applied and the displacement. Now in this case, now he has covered 30 steps each of 20 centimeter of height. So what is the displacement actually? Each of steps is having the height of 20 centimeter. So 20 centimeter means 20 by 100 meter. And how much steps he had covered? That is of 30 steps. So that means the displacement, that is of 6 meter in this case. So what will be the value of the work done? That is of 350 multiplied by of 6, right? That is of 2100 joule. So in this case, the work done by that boy, that is equals to the force that is given here, that is of 350 Newton, and how much distance he has traveled. In this case, he is just stepping out, right? There is the staircase and he is just stepping out. So how much steps he has covered? He has covered 30 steps, each of height 20 centimeter. So 20 centimeter should be converted to meter by dividing 100 multiplied by 30 steps. So that means he had covered only 6 meter. So what is the work done by him? That is of 2100 joule. So in this case, you have to calculate the power developed. So the power developed in this case, that is equals to the work done divided by time. But in this case, the value of time is not given. So the value of work done, that is of 2100 joule divided by 1 second. Just consider that. So it will be 2100 watt. That is of 2.1 kilowatt. That should be the answer of this question. So in this case, the work done that we have got as 2100 joule. So in this case, what will be the power developed? The power developed, that is equals to how much work is done in that amount of time. So in this case, the work done, that is of 2100 divided by the time, right? So in this case, the time, that is equals to 5 seconds. So that should be 420 watt. Thank you so much.